to water. Water is a critical input for agricultural production and plays an important role in our food security. Irrigated water represents 20% of the total cultivated land and contributes 40% of the total food produced worldwide. Irrigated agriculture is on average at least twice as productive per unit of land as rain-fed agriculture, thereby allowing for more product intensification and crop diversification. Important ministries and departments. Now, CWC. CWC is a premier technical organization in India in the field of water resource and is presently functioning as an attached office of Ministry of Water Resource, River Development and Ganga Rejuvenation. Jal Shakti. The Commission is entrusted with general responsibilities of initiating, coordinating, and furthering, in consultation of the state governments concerned, schemes for control, conservation, and utilization of water resources throughout the country for the purposes of flood control, irrigation, navigation, drinking water supply, and water power development. It also undertakes the investigation, construction, and execution of any such schemes as required. Now, Central Groundwater Authority is a statutory body constituted under the Environment Protection Act of 1986. It has the mandate of regulating underground groundwater development and management in the country. National Ganga River Basin Authority was created in 2006 under the Environment Protection Act. It has been replaced by the National Ganga Council chaired by the Prime Minister. Jal Shakti Ministry was formed in the May 2019 by merging two ministries, which are the Ministries of Water Resource, River Development and Ganga Rejuvenation, and Ministry of Drinking Water and Sanitation. Now both ministries have been made departments under the Jal Shakti Ministry. Moving on to irrigation. Irrigation is the process of applying water to crops artificially to fulfill their water requirements. Nutrients may also be provided to the crops through irrigation. The various sources of water for irrigation are wells, ponds, lakes, canals, tube wells, and even dams. There are efficient means of irrigation as well as sprinkler irrigation and drip irrigation. Now, sources of irrigation, we see that a majority of the irrigation is through tube wells. Then canals come at a close second at 15.98%, which is followed by other wells. And we have other wells and other sources which are at meager 2.89% and 2.53, which is 5%. So these figures are in, I think, million. Percentage wise, I think tube wells are the largest at 40%, and then we have other wells at 21%, and at 5% are tanks, at 5% are other sources, and at 29% are canals. Now, wells and tube wells. A well is a hole dug in the ground to obtain subsoil water. An ordinary well is about 3 to 5 meters, while deeper well goes up to 15 meters deep. Well irrigation is popular in areas where sufficient sweet water is available, like Great Northern Plains, deltaic regions of Mahanadi, Krishna, Godavari, and Narbada and Tapi Valley. Problems associated with wells and tube wells are as follows. Wells may dry up in case of water table decline due to overexploitation of groundwater resources. Well irrigation is not possible in areas of brackish groundwater. Only a limited area can be irrigated using wells. It is difficult to dig wells in case of hard rocks and undulating relief. Now, canals. Canal irrigation is the second most important source of irrigation in India. About half of the 165.98 lakh hectares land was irrigated by canals during 2008-9, from which half of the irrigated land was concentrated in the northern plains. Now, to see the canals in India, we have this mission. This would represent the Indira Gandhi. We have Indira Gandhi Kalan area. Now, it starts at Harike Barrage, which is at the meeting point of Satluj River and Bias River, and from there it moves towards Rajasthan. After covering some portion in Punjab, it moves into Rajasthan. Ganganagar is an important city over here. Now, Canal Head will move close to the border and would end up, the tail would end up close to Jaisalmer. Now, this would be the command area of the canal. Now, moving on. Problems associated with canal irrigation are as follows. Any imbalance in water distribution process results in scarcity of water in some areas and water clogging in other areas. Hence, this makes soil unproductive due to movement of harmful underground salts and alkali to the surface level. Stationary water present in canal promotes growth of mosquitoes, which becomes a breeding ground of waterborne diseases. Improper maintenance of canals results in collection of sediments, which in turn affects its capacity. Huge time and investment are required for construction of canals. Now, moving on to tanks. Irrigation tanks or tanks is an artificial reservoir of any size and are mainly found in peninsular part of India. Problems associated with tank irrigations are that they dry up during the dry seasons due to evaporation. Tanks occupy huge areas of otherwise cultivable land. Lifting and carrying water from tanks to the field is a strenuous task. Siltation of tanks is a major issue. Moving on to micro irrigation. Micro irrigation refers to the application of water at low volumes and frequent intervals under low pressure to plant root zones. Sprinkler irrigation and drip irrigations are example of micro irrigation. Now, sprinkler irrigation is a method of applying irrigation water which is similar to natural rainfall. Water is distributed through a system of pipes, usually by pumping. It is then sprayed into air through sprinklers so that it breaks up into small water droplets which falls to the ground. Now, sprinkler irrigation offer advantages like having the ability to administer fertilizers through system for even application as well as ensuring the water flow directly to specific areas, thus avoiding water loss. However, there are certain disadvantages like high initial cost. Wind interferes with the distribution of pattern of water sprays. Clogged nozzles may interfere with sprinkler system. It requires a dependable supply of water. The method of irrigation is generally more suited to high value crops. Now, drip irrigation is sometimes called triple irrigation and involves dripping water into soil at very low rates, that is approximately 2 to 20 liters per hour, from a system of small diameter plastic pipes fitted with outlets called limiters or dippers. Now, water is applied close to plants so that only parts of the soil which is in which the root grow is wetted, unlike sprinkler irrigation, which involves wetting the whole soil profile. Now, this would be the schematic for a drip irrigation system. Now, advantages of drip irrigation are water use efficiency is high, it reduces soil erosion. There is high efficiency in use of fertilizers and there is no runoff of fertilizers into the groundwater. It discourages weed growth as water is delivered close to the plants. Fungal diseases are minimized as there is minimum water contact between with the stems, leaves, and fruits of the plant. However, there are challenges associated with it, like there are issues of clogging, high cost is required in its installation, lack of requisite skills amongst farmers for designing installation and operation, salinity issues are present. Now, check basin and border strip irrigation. Surface irrigation involves the application of water by gravity flow to the surface of field. Over the years, many surface methods of irrigation have been developed. Among them, check basin method of irrigation is the most popular. Check basin is the easiest and least costly method, but it is highly inefficient as only less than 20% of the water is taken up by the plant. Unfortunately, this is also the most widely used method among Indian farmers in different crops and cropping system. Now, furrow irrigation. The furrow method of irrigation is generally used to irrigate row crops, vegetables, and is suited to soils in which the infiltration rate are between zero point 0.5 to 2.5 centimeter per hour. It is ideal for slope varying from 0.2 to 0.5% and a stream size of 1 to 2 liters per second. Many of the field crops in which water is applied through flooding, check basin, or border strips method can easily be adopted for furrow irrigation or its modified version, that is raised bed systems. 20 to 30% saving in irrigation water can be achieved by switching over to raised bed furrow irrigation system. Now, surge flow irrigation, excessive water intake and deep percolation losses are the major limitations for irrigation through furrow and border strips. Surge flow irrigations, which is the intermittent application of water in series of on and off modes of constant or variable time spans, has the potential of reducing intake and percolation losses, increasing the irrigation efficiencies, and conserving irrigation water. Now, subsurface drip irrigation is a low pressure, low volume irrigation system that uses buried tubes to apply water. The applied water moves out of the tubes by soil matrix suction. Wetting occurs around the tube and water moves out in soil in all direction. The potential advantages of subsurface drip irrigation are water conservation, enhanced fertilizer efficiencies, uniform and highly efficient water application, elimination of surface filtration problem and evaporation losses, flexibility in providing frequent and light irrigations, reduce problems of disease and weeds, low pressure required for operations. Now, subsurface irrigation is suitable for almost all crops, especially for high value fruits and vegetables, turfs, and landscapes. The tube is installed below the soil surface either by digging the ditch or by special device pulled by a tractor. Now, the depth of installation depends on the soil characteristic and crop species, ranging from 15 to 20 centimeter for vegetables and field crops and 30 to 50 centimeter for tree crops. The main disadvantages are high cost of initial installation and increased possibility of clogging, especially when poor quality of water is used. Now, deficit irrigation practices in arid and semi arid regions, water availability is usually limited and certainly not enough to achieve total water requirement and maximum yields. Then, irrigation strategy should not be based on full crop water requirement but should be adopted for more effective and rational use of water based on critical or sensitive growth stages to water deficit. Thus, at non sensitive growth stages, irrigation is withheld, which is called deficit irrigation. Now, regulated deficit irrigation (RDI) is an optimizing strategy under which crops are allowed to sustain some degree of water deficit yield and yield reduction. During regulated deficit irrigation, the crop exposed to a certain level of water stress either during a particular period or throughout the growing season. The main objective of RDI is to increase water use efficiencies of the crop by eliminating irrigation that have little impact on yield to improve control of vegetative growth, improve fruit size and quality. Now, RDI is sustainable way to cope with water scarcity since the allowed water deficit favors water saving, control of percolation and runoff return flows, and reduction of losses of fertilizers and agrochemicals. It provides for leaching requirements to cope with the salinity and optimization approach leads to economic viability. The adoption of deficit irrigation implies appropriate knowledge of crop evapotranspiration of crop response to water deficits, including the identification of critical growth stages and economic impact of yield reduction strategies. Now, partial root drying is a new irrigation technique first applied to grapevines that subjects one half of the root system to dry and drying conditions while the other half is irrigated. Wetted and dried sides of the root system alternate on a 7 to 14-day cycle. Partial root drying uses biochemical responses of plants to water stress to achieve balance between vegetative and reproductive growth. The PRD has been successfully applied with drip irrigation in grapevines, with subsurface irrigation in grapevines, and even furrow irrigation in pears, citrus, and grapevines. Improvements of WUE results from partial stomatal closure and reducing evapotranspiration during drying period. Now, irrigation is important for agriculture in the following ways. It helps in increasing the agricultural productivity and food production, which is crucial to meet the food security. It helps counter spatial and temporal variations in rainfall, as well as its uncertainty, irregularity, unreliability, and erratic nature. Irrigation maintains moisture in soil and improves soil health. Irrigation is must for water intensive crops like sugarcane and jute. Introduction of high varieties like genetically modified crops require high amount of water which can be supplied through irrigation. While irrigation is needed to increase agricultural productivity and meet the rising food security needs of the growing population, it is a matter of concern that about 60% of the total cropped area is still dependent on rain. Irrigation sector in India faces number of problems that need attention. Like in most of the irrigation projects, there have been considerable delays in project completion. Irrigation system being a state subject, development of water resources is planned individually by states taking into account their own requirements. However, nearly all major rivers are interstate, which often leads to interstate water disputes. Inadequate on farm and off farm infrastructure and poor maintenance leads to poor irrigation efficiency. Regional disparities are also visible in irrigation infrastructure development. Introduction of irrigation has also led to the issue of waterlogging and salinity in states. Huge investment is required for operating and maintaining irrigation networks, causing financial strains on the governments. Decline in water due to overexploitation of water has affected our irrigation capacity. To address the challenges, following irrigation management measures are required. Building proper infrastructures like canals for adequate and regular water supply. A proper drainage system needs to be put in place, addressing the issue of water clogging and salinity in major irrigation commands. Irrigation efficiency needs to be improved through steps like micro irrigation. Improving water productivity through steps like water should be priced at a level enough to motivate farmers to save water. Energy subsidy for pumping water should be abandoned. Biological water saving measures, engineering solutions, agronomic and soil manipulation should be collectively explored. Water intensive crops should be cultivated in lands with abundant groundwater availability. In areas with groundwater shortages, drought resistant crops like maize should be grown. Now, Pradhan Mantri Sinchai Yojana. Pradhan Mantri Sinchai Yojana is a national mission under the Ministry of Agriculture, Farmer Welfare to improve farm productivity and better utilization of resources in the country. The scheme has been approved with an outlay of 50,000 crore for the period of 5 years between 2015-16 to 1920. Major objectives of the schemes were convergence of investment in agriculture at field level, expand cultivable area under irrigation, improve on-farm water use efficiency to reduce wastage of water, enhance the adoption of being precise in irrigation and other water saving technologies, more crop per drop. Now, Pradhan Mantri Kisai Sinchai Yojana District Irrigation Plan Program Components. AIBP focus on completion of ongoing major irrigation projects, medium irrigation projects, and national projects. हर खेत को पानी, creation of new water resources, RRR of water bodies, CAD, groundwater development, programs like Niru Chetu and diversion and LI, per drop more crop, efficient water conservation and precise application, topping input cost limits, micro irrigation and secondary storage structure, lifting devices, scientific means, training, awareness and ICT, use of ICT, watershed development, runoff management and water harvesting, improved soil and moisture conservation, converging with Manrega for creation of water sources, renovation of traditional water bodies. Now, Pradhan Mantri Kisan Urja Suraksha Evam Utthan Maha that is PM Kusum. PM Kusum motion has been launched recently by the Ministry of New and Renewable Energy. The scheme aims to provide energy security along with financial and water security to farmers. It will encourage farmers to generate solar power in their farms. The target is to add decentralized solar power capacity of 25,750 megawatts by 2022. Component of Kusum schemes are component A, B, and C. A refers to 10 gigawatts of decentralized groundwater mounted, grid connected renewable power plants. Component B is installation of 2 million standalone solar pumps. And component C is the solarization of 1.5 million grid connected solar powered agricultural pumps. Farmers can sell their surplus solar power generated off grid to discoms, thereby increasing their income. Now, moving on to Atal Bhujal Yojana. Atal Bhujal Yojana has been launched by the Ministry of Jal Shakti. It is a central sector scheme to improve groundwater management through community participation. 7 states are covered under the scheme, which are Gujarat, Haryana, Karnataka, Madhya Pradesh, Rajasthan, and Uttar Pradesh. It is being implemented starting 2020 over a period of 5 years with 50% support from World Bank. Now, miscellaneous provisions. Now, Namami Gange program is an integrated conservation mission under the National Mission for Clean Ganga with a budget outlay of rupees 20,000 crore to accomplish the twin objectives of effective abatement of pollution along with conservation and rejuvenation of Ganga. Initiative under the Namami Gange include Ganga Gram Yojana, which includes 1600 villages situated along the bank of River Ganga, will be developed. Ganga Task Force will be created. Now, Jal Shakti Abhiyan is a time bound mission mode water conservation campaign launched by the Jal Shakti Ministry. The Jal Shakti Abhiyan ran in 2 phases, that is, phase 1 from 1st July to 15th September 2019 for all states and union territories, and phase 2 from 1st of October to 30th of November 2019 for states and union territories receiving retreating monsoons, which are the states of Andhra Pradesh, Karnataka, Puducherry, and Tamil Nadu. Now, during the campaign, officers, groundwater experts, and scientists from Government of India will together work with the state and district officials in India's most water-stressed districts for water conservation, water resource management by focusing on accelerated development of five target interventions. Now, Jal Jeevan Mission is an initiative by the Jal Shakti Ministry to ensure piped water supply to all rural households by 2024. Cities with more than a million population in 2020 itself. The mission will focus on rainwater harvesting, groundwater recharge, and using household wastewater to reuse in agriculture. National Rural Drinking Water Program will be subsumed under the JJM to ensure convergence of different schemes. Long Term Irrigation Fund is a fund under the National Bank for Agriculture and Rural Development, that is NABARD, for implementation of major and medium irrigation projects in India. Under the fund, 20,000 crore is to be raised. Likewise, micro irrigation fund with a corpus of 5,000 crore rupees has been created with NABARD with the aim of enhancing water use efficiency at farm level. Now, moving on to watershed management in India, a watershed is an area of land that drains or sheds water into specific water bodies. This would be the watershed: biomass, energy resource, water resource, pasture, soil resource, human resource, mineral resource, etc. So these things all come under watershed. Now, National Watershed Project, which is a land World Bank assisted watershed management project, involves conservation, regeneration, as well as judicious use of all resources like land, water, animals, plants, humans within the watershed area. The National Watershed Project has led to an increase in the agricultural production from water stressed areas. It has led to a reduction in surface runoff, thus increasing groundwater recharge, soil moisture, and better water availability in water stressed areas. Optimum utilization of natural resources like land and water has resulted in increasing agricultural productivity and cropping intensity. Further, the project helped in restoration of ecological balance in fragile water-stressed areas by increasing vegetative covers and decreasing soil erosion through afforestation. It also helped farmers adapt to climate change and mitigate the adverse effects of drought by adopting sustainable agricultural practices. Another big achievement of the project is that it has led to community participation in conserving water. Now, existential water crisis in India. As per Niti Aayog, we are facing the worst water crisis in India's history. It launched the Composite Water Management Index to assess and improve the performance of states and union territories in efficient management of water resources. The 2018 Composite Water Management Index noted that 6% of economic GDP will be lost by 2050, while water demand will exceed the available supply by 2030. My goodness. Now, the index comprises nine broad sectors covering 28 say, indicators. Now, the nine broad sectors are source augmentation and restoration of water bodies, source augmentation of groundwaters, major and medium irrigation supply side management, watershed development and supply side management, participatory irrigation practices, demand side management, sustainable on farm water use practices for demand side management, rural drinking water, urban water supply and sanitation, policy and governance. Now, the nine sectors cover 28 indicators with the weights equally divided across a sector indicator. Now, focus on groundwater irrigation and quality action, highlighting the growing groundwater India, low irrigation utilization, and importance of effective quality framework. Now, baseline of water stress. These regions have low to medium water stress, whereas we see that Western India is highly water stressed. Similarly, the region of the Indian peninsula lying between the Western Ghats to the eastern coast is water stressed. Also, we see that parts of Odisha is water stressed, especially in the coastal regions. However, parts of Bihar, South Bihar especially, and Jharkhand and Northeast, and some parts of Chhattisgarh and Odisha have low water stress. However, most of the country is water stressed. Owing to its sizable agricultural export, India has been losing water, thereby putting its water sustainability at risk. For example, in 2014-15, India exported 37.2 lakh tons of basmati. To export this rice, the country used approximately 10 trillion liters of water. To put it another way, India virtually exported 10 trillion liters of water. Now, due to this existential water crisis, food supply is also at the risk as areas for wheat cultivation and rice cultivation face extreme water scarcity. To address the crisis, government needs to work on steps like groundwater recharging project, micro irrigation, and legislative changes to promote water management. Now, water pricing can be implemented so as to promote judicious use of water. Water tax should be introduced for companies which overexploit water resources. Now, Rainfed Area Development Program. Rainfed Area Development Program, which adopts a holistic approach to enhance farmers' income in rainfed areas, was implemented in 22 states in 2013-14. It was implemented as a sub-scheme of Rashtriya Krishi Vikas Yojana with the following objectives: to improve the quality of life of farmers, especially small and marginal farmers, by offering a complete package of activities to maximize farm return. Increasing agricultural productivity of rain-fed agriculture in sustainable manner by adopting appropriate farming system based approach to minimize the adverse impact of possible crop failure due to drought, flood, or uneven rainfall distribution through diversified and composite farming system. Restoration of confidence in rain-fed agriculture by creating sustained employment and opportunities through improved on-farm technologies and cultivation practices. Enhancement of farmers' income and livelihood support for reduction of poverty in rain-fed areas. The strategy would focus on multi-cropping, rotational cropping, intercropping, and mixed cropping along with allied activities that include horticulture, livestock, etc. This would not only maximize farm returns but also mitigate the impact of flood, droughts, etc. Now, drought prone area program. The basic objective of the program is to minimize the adverse effect of droughts on production of crops and livestock and productivity of the land, water, human resource, and ultimately leading to drought proofing of affected areas. The program also aims to promote overall economic development, improving the socio-economic conditions of the resource poor and disadvantaged sections inhabiting the program area. Now, river interlinking project. We have approximately 16 river interlinking projects. To name them, we have the Mahanadi Godavari interlinking project. Then we have the Godavari Krishna interlinking project. Then we have Godavari Krishna interlinking project again. Then we have the Godavari Krishna interlinking project. Then we have Krishna Pennar interlinking project. Then we have Krishna Pennar Kaveri interlinking project, which is here. Now we have Kaveri Vaigagi Gundar interlinking project right over here. Then we have Ken Betwa, which should be here, right over here. Now these are tributaries of Nabata, I guess. Yes, not Nabata. Sorry, Yamuna. Moving on, the interlinking of river projects is to transfer water from water surplus rivers to rivers with deficit water. The project aims to effectively manage the water resource in India by linking Indian rivers by a network of reservoirs and canals to enhance irrigation and groundwater recharge, reduce persistent floods in some parts, and water shortages in other parts of India. However, there are certain concerns regarding the project, like huge investment is required by the project. Ecological and environmental issues are involved in projects like deforestation, desertification, land and forest submergence. Example, the Kane Betwa project will lead to the submergence of core area of Panna National Park. It will lead to the displacement of people. There will be big problems of desilting, and there is no clarity as to where silts will be actually dumped. A major issue in India relates to interlinking of rivers is that water is a state subject and states have surplus water are not ready to give it to other states. That'll be it.